This is a tutorial on the general branch of the Zone 1 section in WUFI Passive. So in WUFI Passive, you can build out multiple zones in your project if you'd like, and they are shown in your project as different branches. When you're in the Zone 1 branch, there's only kind of one tab or one input screen over here, and we're going to walk through the different entries here. So you could name your zone. This one we called interior or inside. You select now if this is a simulated zone or an attached zone. So this is very important. A simulated zone is a zone that you would like to include within the passive building thermal envelope. So if you'd like results for that zone, if you'd like to include that in the heat loss, heat gain calculations, you need to include it as a simulated zone. An attached zone might be something like an unheated basement, a garage, something that's in the 3D geometry that you're not actually calculating as part of the thermal envelope. So I'm going to keep it as a simulated zone. And then it's within the PH case residential here. Okay, so after we set that up, there's some specifics in geometry that we need to enter. So the first one you'll see here is the visualized volume, roughly 25,000 cubic feet. This comes in from the 3D geometry we've imported. So it's good to just kind of get a quick glimpse of this to ensure that it looks reasonable relative to what you were expecting for your building. If it's not reasonable, something with scale could be off, or just make sure that passes the test. So that one is not a changeable value. That's just kind of a reference value that shows you what the geometry of the imported model is. The next entry here is the gross volume. So this is the volume measured to the outer extents of the thermal boundary. If we've drawn our SketchUp model properly for import or our GBXML file, the gross volume should be identical to the visualized volume. You should have drawn to the exterior extents of the thermal boundary. So what I'm going to do is I'm going to go ahead and just detect this by clicking into it and say, go ahead and take that from the visualized volume. My gross volume should be the same. But again, make sure this is what you'd expect for the gross volume. If not, it might be signaling that there's some sort of error in your geometry. Or potentially, if one of your components is facing the wrong way or another, it might detect an odd volume there because it can't figure out how it's all enclosed. So that kind of just gives you a signal that something could be wrong with your geometry. Okay. The third entry down is the net volume. So this is an entry that requires kind of a detailed calculation. For preliminary modeling, I'd say you can go ahead and use one of these estimated drop-down options. Estimate from gross volume is generally one I would select. But when you're certifying a project, you actually need to do this calculation. And what this is it's the actual interior volume minus your structures, so your wall, your floor structure, your stairs, minus kind of all that actual structure. And it's measured to the interior of the exterior wall, kind of where this orange is shown, rather than the gross volume, which was taken from the very outer boundary here. So this particular project did a calculation for us. So they measured to the sheetrock or the drywall on the inside, and then they subtracted the walls, first floor, second floor, the actual floor structure, and determined that the net air volume is 16,000. Let's get a little closer here. 16,326 cubic feet. So we'll go ahead and take that, but again, this is a detailed calculation that you'll need to do for your project. You can also use this kind of ... pop-out calculator in WUFI Passive and do your own calculation within this. So if I knew it was 500 times 8 feet in height plus, I could add up room by room if I wanted to, or you can obviously do the calculation externally. The next entry down is the interior conditioned floor area. So this is definitely one that I would make sure you're pretty comfortable with the number, or it's pretty accurate even with initial modeling. The reasoning is all your final results here, heating demand, heating load, and cooling load, are divided by this ICFA, or this interior conditioned floor area value. So if you're off by 10, 20, 15%, your results are also off by that much. So you could either be passing or failing based on this value, and if that skews one direction or the other, your results will change per square foot. So this is important to kind of get right. Okay, so for this particular project, let's take a look. So you'll see that the orange here is kind of outlining where the ICFA is measured. The general rule is that it's all spaces that are at least 7 feet in height and are walkable. Stairs count, shelving counts, hallways count. I mean, everything counts at 100%, as long as it's walkable. So open to below spaces obviously don't count on that second floor that you'd see in the plan. Stairs count on both levels is shown here, so the entire staircase is shown for both. So really the ICFA for each of these floors is identical. So if we get a little closer here, you can see this was calculated for this project as 965.8 square foot per floor, totaling up to 1,931.6 square feet total. So again, make sure you're doing this detailed calculation. And it's really just drawing a line at the interior face of your exterior drywall and getting an area from that. And again, spaces must be 7 feet in height to count. If they're below 7 feet in height, they do not count. They count at 0. And the specific heat capacity we will get into with a separate tutorial, so look out for that one.